Remember that. So you have to be very, very careful. So in this case, we have, so this is the formula, id squared over 2 geometry. So we place, what is pi? 3 points. What's the diameter of the given of the spaces in it? 7.42. That's the numerator, right? Divided by, this one is in. So this one is supposed to be square. This is supposed to be square, isn't it? So many given the meters there will square. So when you calculate that. That is how we found it. So 7.42 square multiplied by the 1.2. What the value you find inside everything by 4. Then we find the that's a 3.2 for that we come and
Madam, I don't think it's recording. Can't see it. I don't think it's recording.
I don't think it. No, I can see it.
Oh.
Yeah.
Okay. So it's fine.
Now I just need to allow you to share your screen. You cannot share, but the video. Okay, so let me just make sure this. Okay, so modulus of extension is equal to force multiplied by original length divided by original cross-sectional area multiplied by extension that we picked from, isn't it, from the elastic region. We have that sorted out. So our answer is 185 MPa. So how did we come here? MPa. Let's come back here. What do we have? So I had mentioned this online, and I'll mention again. So here, what do we have? Force is in what? We converted it into newtons. Remember? So we have newtons multiplied by, which is in, divided by, cross-sectional area is in what? As this still falls. Multiplied by extension is in x. Extension is what? So this is the cocktail of units that we have here. So mathematically, what are we doing? Remember, force, newton, length, millimeters. This one is in square millimeters, and this one is in millimeters. Okay, so what's cancelling? What here? This will cancel. Then what are we left with? Newtons divided by. Okay. So according to physics, what is Newton's per millimeter squared? Okay, so we borrow from physics here. 1 Newton per millimeter squared is equal to what? 1 megapascal. Are we together? Take note of this. 1 megapascal is equal to what? How many pascals? 1,000 pascals, isn't it? Then there's one that we like to use. in gigapascals. So 1 gigapascal is equal to how many pascals? How many megapascals? You will determine that one on your own. Okay, so sometimes I'll tell you to answer in gigapascals. Then you remember this again. Okay, let's move on. Let's move on further. To will always be divided by original plus sectional area. That point here. Okay, so let's solve for this. Tell me what answers it. Pardon? 0 point? You did not convert your newtons, your kilonewtons to newtons. So remember, here, there's no Kn, okay? So you need to make sure that you convert your kilonewtons that you have here. You automatically convert them to newtons, okay? Then that's when you place here. Or you place here and multiply by.
So 890.
8?
890.
Yes, 890 MPa. Try and calculate. I'll give you a minute to calculate your point just to make sure that we all get the same answer. Memory. You found it? No? What's the challenge? When in the exam you need it. I'll be able to calculate that one. Use your phone. For now, use your phone. Okay, so ultimate tensile strength is equal to F max over. So you have 890 MPa. We move on. Can we move on? How many have you understood? Sure. We move on. Okay, so let's come to number 4 here. Let's find the 0.1% proof stress. 0.1% stress. How do we find it? What is it? So the proof stress is what helps us determine the yield point. What is the yield point? The yield point is basically where the elastic region is ending, and we are now beginning there. We're entering the plastic, isn't it? From elastic to plastic region. So where the elastic region is ending and connecting us to the plastic region, right? So we need to know that that yield, and that is where now the material, just like in since it's now yielding to the stress. When you start yielding to the stress, okay, new life balance. Start entering. So in your life, you need to know which point. Each one has that point, hey, where once you bypass it, things start happening. Okay, so it means that now that the plastic deformation becomes permanent, isn't it? The effects now become permanent. Am I making sense? So now, even with materials, when they are, as you are stretching them, applying stress on them, there's going to reach a point where that particular stress will be enough to make them not be able to return to their original length. Okay, so in your case, look at your graphs. Are you able to tell that point? Where is it? I don't think you're able to. So in other graphs, depending on the, sometimes they'll be like, when a graph is like that, when it has that small depression, it's a bit easier to tell where the elastic region is ending and where you are entering. So that becomes your yield point. This is supposed to be F yield, the force at the yield. But in your case where it's smooth, it's a bit hard. So what do? We give an allowance of 0.1%. That is what we call the proof stress. So it means that we'll kind of put it as 0.1% here, and then draw a parallel line, a line parallel to the elastic region. We'll draw that line like that. Okay, so when it exceeds there, we draw a parallel there, and that becomes our F unit. Okay, so we give an allowance of 0.1%. That is what we do in order for us to find that point that is demarcating the elastic region from the plastic region. We're together? Okay, so now let's look at what we have. How are we going to achieve this? There's nothing hard here. That's the mindset. Come with the correct mindset. That's very simple. Okay, so what do we have here? 0.1% of stress. So we find 0.1% of the original length. Okay, what's the original length? Look at the question. Yes. So, what is 0.1% of 40 millimeters? That's the question. Grade what? Grade 10. You're supposed to change from percentage to what one is 9. So it's the same thing here. So how do we remove this? Mathematically, we say 0.1 divided by what? Then that value we find here, we're going to, of means what? Times, isn't it? So this value we find here, we're going to multiply it by 40. Do likewise, tell me what you find. 0 point? So you have found 0.04. Remember?
So you can draw that here. Before you move on, madam, we said there's 0.04. When you don't the 0.1, you didn't finish. You said there's 0.1.
Yes, I wanted to know if you got it. You found it on your what x-axis? The x-axis. Then you're going to get a ruler, and that's what you need a set square. Does anyone have a set square? The triangle. It's my triangle.